Today we're going to learn about graphing linear inequalities. Up to this point, you have graphed linear equations. You've graphed functions that look just like linear equations. And now today, you're going to graph something called a linear inequality. Remember, equations possess an equal sign, whereas inequalities will be greater than, perhaps less than, greater than or equal to, less than or equal to. And this is what we are going to learn to graph today. So, open your books to 436. Remember, those definitions are important. You are responsible for knowing what those things are. First off, we've got a bowl and vase story that we're going to talk about at example 4. But linear inequalities are equations that look very similar to linear equations, only you end up with these signs. So let's look at example 1 just to start out with. Example 1, and it says, tell whether the ordered pair is a solution of, and this is the equation or the inequality, 2x minus 3y is less than 6. So the first set they've given us is 0 and 1. Obviously, you recall that 0 is x and 1 is y. So let's plug in 0 for x, 1 for y, and let's determine negative 3, is that indeed less than 6? You bet it is. Okay, so yes, we are dealing with a solution that would fit. As you know, there are many more solutions, but we can start with that. Now B, we're going to use the same equation again, only they've given us 4 and negative 2 as our coordinates. 2 times 4 minus 3 times negative 2, is that less than 6? 8. So a negative times a negative is a positive. False. No good. So the answer is going to be no. The answer is going to be no because 14 is not less than 6. Now we can actually graph linear inequalities quite easily, and they give you a definition or a note card that you can copy at the top of page 437. But I am going to illustrate how to do that as I go through example 2. Okay, so you can read that note card sample. If you want to pause and read that, you can. Graph. This is example 2. Y is greater than or equal to 2x plus 4. Now, you are going to graph this to start with in your mind as if it is an equality. Okay? Start by noticing that your y-intercept is still 4 and your slope is still 2. That's 2 over 1 for those of you that are thinking about how you move. So I am going to create a quick graph, and my y-intercept is 4, 1, 2, 3, 4, and I'm going to go up 2 over 1 for my line. This is where it changes, okay? For less thans and greater thans, you use a dotted line. I'll show you what that means in a minute. For less than or equal to's, greater than or equal to's, you create a solid line. Okay, remember we just made a line before. Okay, now this is where it changes a bit. Do I draw a dotted or do I draw a solid? Clearly I'm going to draw a solid because not only is it greater than, but it is also equal to, which means anything that falls on this line is included in the solution, in addition to items that are greater. Okay? So we've picked which scenario fits. We've graphed our y-intercept and our slope. here is the step that makes it tough. Test a point either above or below your line. Okay? True, then graph or shade that entire section. You'll see what I mean in a minute. False, shade other section. Now, just to give you a little bit of terminology, this or this is what's going to be shaded, depending upon what we test and whether or not it's true or false. I always try to test the 0, 0 point, which is your origin, right? Pretty stinking easy to fill in 0, 0 as a value. Okay, so this is going to be my test. If it's true, I'm going to shade here. If it's false, that means this is wrong. The other side satisfies the greater than portion. So here we go. 0 is greater than or equal to 2 times 0 plus 4. 0 is greater than 4. True or false? Clearly that's false. Which means the 0, 0 resulted in a false, so you're going to shade the other side. I used up a little too much of my space, but I'm going to go ahead and shade the other side. A lot of times, people will use an alternate color just to make it clear, okay, that I have indicated that this side, this plane, this half plane, if you will, is what is true. This half plane is not, okay? That's one example for you, okay? We've graphed. We're going to graph another one, and it's going to be from the checkpoint. I want to follow along with that really quick. This is going to be checkpoint 1. Checkpoint 1. Graph x plus 2y is greater than 6. Okay, we're going to treat it as if it's an equal sign, but first we need to get it into y equals mx plus b form. Step 1, subtract your x. Negative x plus 6. Remember, you want your mx here and your b there. Okay? Divide by 2. Dividing by 2 is the same thing as multiplying by the reciprocal of 2, which is 1/2. Y is greater than, it was a negative, 1/2 x plus 3. That is what I'm going to graph. Y-intercept is 3. Item has a downward slope. How do I know that? Because it's a negative. So it's going to head this way. 3. Down 1, right 2. Greater than. What were these scenarios? Dotted or solid? If you remember, I wrote all that down. Dotted for only less than or only greater than. Solid if those items are coupled with an and equal to. Okay? So this is greater than, therefore dotted. And this is critical. You cannot err on this. Okay? By making it dotted, I have told you that it is a greater than or less than scenario. Okay? What do I shade? Do I shade here or here? As long as the origin is not on the line, I test it. And the origin is in this lower plane, this lower half plane, so I'm going to use that 0, 0 point. If it's true, I will shade this. If it's false, I will shade above. 0 is greater than negative 1/2 times 0 plus 3. Is 0 greater than 3? Nope. Okay, not true. So we're going to shade the above up here. Okay, that is the correct shading. Moving on. Let's do example 3 together, and then I've got a couple more practice. Example 3. Example 3 says graph x is less than 3 and y is greater than or equal to -2. We're going to graph those separately, by the way. They're not saying to graph them together. So my first one I'm going to do is x is less than 3. Okay? Graph it as if it is an equal sign. Okay? So if x is always 3, that means my right-left movement is always a 3 and up-down anywhere. Okay? Right, oh, that's a 2, silly. Sorry. Right 3. Okay? Any up-down, but right 3. Now, still, we have to test. Because it's less than or greater than, we have to shade what values would work. And you're probably going to just see right off the bat that if I plug in a value of 0, 0 is less than 3, you can see that it's a true statement. So I'm going to shade everything that includes the truth that I've uncovered. Okay? And that's that. It doesn't have to be perfect, but I do like it to be neat. So this is the first one. The second one was, by the way, remember this is no slope or undefined, if you remember that terminology. Y is greater than or equal to -2, which means any right-left value, any x, but always down -2, which is down here. Okay, greater than or equal to means solid line. Okay, I hate that it's 2 arrows like that, so I'm going to make it clear that this is what I've got, just like this was what I had here. The straight lines just bug me. Okay? Now, what do? We test the origin because it's not on the line. That location is 0, 0. Is 0 greater than or equal to -2? That is true. 0 indeed does fall greater than -2. Therefore, since it's a true statement, we shade what is above our solid line. That was solid because it includes the equal to. Okay? We're going to do just a couple more practice items like that. Similar to the first one, 3A is checkpoint number 2. Okay? I'm going to squeeze that right next to it. X is greater than or equal to -1, which means always to the -1 left, but any up-down. There's -1. Solid line because it's and equal to, okay? Solid line because it is and equal to, greater than or equal to. I'm going to test 0, 0 again because it's not on the line. 0 is greater than or equal to -1. Is 0 greater than -1? You bet it is. Shade, 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 shade. Okay? Checkpoint 3 is similar to the example 3B. Checkpoint 3, here we go. Y is less than 3. If y is less than 3, that means any x, but always up 3. Okay? So that would mean that x can be 1, x could be 2, x could be 3, but always up 3. Dotted line, because it's not on the line, it's not equal to the line, it's only less than the line. Let's test 0, 0. This is pretty obvious. 0 is less than 3. 0 is indeed less than 3. Shade the item below, because that tells you that the rest of the solution set goes this way. Okay? Moving on to example 4. Example 4. This is where that picture on the front page came from, the first part of the lesson. We're making clay bowls and vases. you need 5 pounds per bowl and 2 pounds per vase. Write an inequality describing the possible number of bowls and vases that you can make. Well, they've already kind of made it, laid it out real nice for you. Okay, I know I need, I'm going to call bowls my X and vases Y. I'm not sure, is that what they did? Yes, they did, okay? So I know I need 5 pounds per bowl, and I know I need 2 pounds per vase, and I only have a total of 100 pounds. So knowing that I have that total, okay, I can make any combination of these as long as it is less than or equal to 100 pounds. Originally I had it equal to, but maybe I don't want to use up all my clay. It doesn't matter, okay? I don't have to use up all my clay. I just need to know kind of an area where I can build vases, okay? So first, we're going to make it into y equals mx plus b form in order to graph it, okay? To do that, I'm going to subtract my 5x. 2y is less than or equal to 5x plus 100. Divide everything by 2, and I get y is less than or equal to negative 5 halves x. There's my slope, plus 100. Okay, my y-intercept is at 100. Oh, no, I mean 2. I'm 50, Mrs. Myers. My y-intercept is going to be at 50. So now that I have that information, I can graph. Now I'm only going to need the positive part, positive, because you can't make a negative number of vases. Okay? So 10, 20, 30, 40, 50. Okay? And we've already established that 50 is my y-intercept after we divided by 2. Okay? Continuing, my slope, 1, 2, 3, 4, 5, 1, 2, goes here. Okay? And that is also at 20. Okay? Now, less than or equal to forces me to have a solid line. Now, that line is not going to go above or below. Okay? Not going to go above or below. Now you're thinking to yourself, well, what should I shade? Well, clearly, you're going to understand that you're not going to be able to make more bowls. If you think about it, if you just plug in like a 30, 0, 30, it's not going to work. Let me show you what I mean. Let's test our 0, 0. And in this equation right here, 0 is less than or equal to 5 halves times 0, which is 0, plus 50. Yes, that's true. So obviously this section illustrates the quantity of vases and bowls that I can make. Okay, I could make 10 vases and 10 bowls if I wanted. Why? Because it lies within the section that I have enough clay for. In contrast, I cannot make 20 and 20 because if I have 5 times 20 and I add 2 times 20 together, I will have a number larger than the 100 pounds that I have available. Okay? So anything outside of the shaded area is not going to be possible. Okay? The maximum number of the bowls I could make is 20. That would mean I make no vases. The maximum number of vases I can make is 50. But that means I can make 0 bowls. That's why the 0, 0 is important. I'm going to let you guys go ahead and get started.